Hi everyone, welcome to Raaonline. This is Dr. Srivatsan, your faculty for biochemistry, and in today's session we will be speaking about sphingolipidosis. Okay, before going to the proper topic of sphingolipidosis, let me try to explain what exactly is a sphingolipid. Okay, and what is a glycolipid. Okay, sphingolipids are the one which has got sphingosine as its backbone alcohol. So this backbone alcohol will be sphingosine. Okay, to this backbone alcohol, a fatty acyl CoA or fatty acid will get attached to what linkages? Through ester linkage. Okay, ester linkages are C double bond O R dash. So this is ester linkage. Okay, alcohol and an acid combining. Okay, so this is called as sphingolipid. Okay, so when some kind of an additional group, something like a carbohydrate, when it comes and attaches to this sphingolipid, okay, they are called as glycosphingolipid. Clear? So are you clear with the terminology? Glycosphingolipid. It has got a sphingosine backbone with a fatty acid attached to one side and a carbohydrate moiety attached on another carbon. Okay, so as I said before, the carbohydrate units are there. This carbohydrate unit could either be a monosaccharide, or this could be an oligosaccharide, or this could be an oligosaccharide associated with sialic acid. Okay, so according to that, the name actually changes. Okay, so for example, if that carbohydrate unit appears to be a monosaccharide, then this is called as cerebroside. Okay, so this is called as a cerebroside. So examples of monosaccharides, I will take two examples here. One should be glucose. If that monosaccharide happens to be glucose, this is called as glucocerebroside. Clear? Okay. So glucocerebrosides. So these glucocerebrosides form major components in various kinds of tissues, and the major peculiarity of these tissues is that these tissues usually will be non-neural tissues. Please remember this, the glucocerebroside will form part of various kinds of sphingolipids in various tissues, but mostly these tissues will be non-neural tissues. Okay, we have got another monosaccharide which is galactose. Okay, this galactose, if it becomes the additional group here, then this becomes galactocerebroside. Okay, so the galactocerebroside, they actually form the major component of neural tissues in your body. Clear? So please remember guys, in case of glucose, the glucocerebroside forms the major component in non-neural tissues, whereas galactocerebroside forms the major component in neural tissues. Okay, it has got this clinical context. I will explain later on. So what is the rationale behind stressing out this point? Okay, as I said before, now we have got oligosaccharides. Okay, so oligosaccharide, if that additional group happens to be oligosaccharide, then this is called as globoside. Okay, if this additional group happens to be an oligosaccharide, this is called as a globoside. Okay, now we have got another set called as oligosaccharide, which is associated with NANA, otherwise called as NANA or N-acetyl nuraminic acid. It is otherwise called as sialic acid. Okay, so this, the structure will be, we have got the central sphingosine alcohol here, we have got the fatty acid here, okay, and we have got the oligosaccharides here, and finally there will be sialic acid attached to one end. Okay, this will be the structure for gangliosides. Okay, so these, they are called as gangliosides, and these gangliosides will be named as GM1, GM2, GM3 and so on. Okay, so what is the what is the meaning for this G? What is this G here? The G stands for ganglioside. Okay, so what is this M? M stands for monosialic acid, otherwise called as the sialic acid or N-acetyl nuraminic acid. N-acetyl neuramic acid. Okay, so this is the sialic acid. Clear? And this 1, 2 and 3, what are those numbers? This 1, 2 and 3, what are those numbers actually? These numbers are the one which actually denotes the chromatographic motility of these kind of gangliosides. Okay, so when these gangliosides are present on a chromatographic chamber, okay, so these actually starts moving. Okay, so the 1, 2 and 3 actually denotes the chromatographic mobility of those kind of gangliosides. Okay, so guess what? Which one is the simplest ganglioside among these three? The simplest ganglioside is GM3 ganglioside. This is the simplest ganglioside. Okay, and GM1 ganglioside will be the most complex ganglioside. Okay, and this ganglioside actually acts as a receptor for cholera toxin in your intestines. Clear? And these gangliosides usually act as receptors mostly, guys. Okay, and this GM1 is a specialized receptor for receiving the cholera toxin in your intestines.